I want to introduce you guys to a highly lucrative niche of data science. In this role, you will be getting asked the question, what is the impact of? And it could be marketing campaigns, product launches, policy changes, outages, any sort of event that has happened. This niche of data science is called causal inference. Now, unlike many machine learning models, we're not simply looking to make predictions. We're actually looking for causality. So in prediction problems, you may have two things that are highly correlated, and knowing one feature can predict the outcome that you're looking for. But that does not imply a causal relationship where if you change the feature on one person, that it'll make you more or less likely to have that outcome. Now, in general, there are two major areas of causal inference. The first is experimentation. Experimentation is the gold standard for what's the impact problems. Under randomized experimentation, when you have a treatment and a control group, the only difference between the two groups, both on observed and unobserved characteristics, is the treatment itself. And that allows you a clean estimate, a clean identification of the effect of the treatment on the outcome you're looking for. But where the big money comes in causal inference is in the observational studies. This is how do we estimate the impact of these actions when experimentation is not an option. So the first thing you need to do is recognize situations where experimentation is not an option. What could these be? So the first case, the obvious one, is the event or the treatment already happened in the past. Now, this happens all the time. A stakeholder launches a product change, and then they come to you, the data scientist, after the fact, and they say, hey, what was the impact of this big product change that we did? Obviously, you don't have a time machine. You can't go back and set up an experiment. Time for observational causal inference. The second might be it's just not feasible or legal or moral to be able to do randomized experimentation. This comes up a lot in the public policy realm. For example, the government can't just randomize different student loan interest rates to people. And you can't really randomize people into, let's say, a recession to see the effect of a recession on college going. A third reason is you may not have the budget for it. So let's say you want to do a marketing campaign where you're putting up these huge billboards on the side of the road. You might not have enough money to market and put up billboards scattered throughout the country. Maybe you can only pick one city that you can do this campaign in. Observational causal inference. And then another common one is understanding the effect of bad events. For example, let's say a website has an outage, right? Or like your AWS and AWS goes down, or a UPS delivery is late. These are bad events that a company doesn't want to just assign to you through randomized trials. They want to minimize it as much as possible, but they're still interested in knowing the impact when these things have already occurred in the past, hence observational causal inference.